In learning objective B and C, we're going to evaluate functions and give numerical output, and we're also going to evaluate them and just keep them in their expression format with the variables still there. Now, let me just refresh your brain on how to say this. When you see this notation, it is said as f of x. We're going to be using this a lot this year. So suppose we have the function defined by this rule, that f of x is equal to 4 times 1/2 to the x power, okay, for all real numbers. They want us to evaluate f of 5. Well, easy enough to do. All it means is, notice what they did is they replaced x with 5. So you come in here, and wherever you see x, you're going to put the 5. So f of 5 is therefore equal to 4 times 1/2 to the 5th power. Now, I want to keep this as a fraction answer. I don't want to use my calculator and get a decimal. So let's review. What do you do when there's an exponent on the outside? Well, that exponent goes to both of these numbers. So that means it's 4 times 1 to the 5th power over 2 to the 5th power. And that's going to simplify. 1 to the 5th is 1. 2 to the 5th, be careful, is 32. To multiply a whole number in a fraction, you just put it over 1, multiply straight across. So 4 over 32 is therefore then going to simplify to 1/8. So that is our final answer. Now, the second question is wondering, what if we use the same function? What if we find f of -2 plus 3 versus what if we find f of -2 and then add to it f of 3? Is that going to give us the same answer? Well, let's test it out. F of -2 plus 3 is really just asking us for f of 1, is all it wants. So I'm going to use our equation up here and just put 1 in for x. So that would be 4 times 1/2 to the 1st power. 4 times 1/2 is going to be 2. Okay, so this side equals 2. Well, is that going to be the same? Well, let's do this. F of -2. So for that one, it's going to be 4 times 1/2 to the -2. And then I'm going to do plus 4 times 1/2 to the +3. Okay, so I'm going to distribute that exponent to both sides here really quick first. And then we're going to have 4, 1 cubed, and 2 cubed. Now, this is worth looking at. Hopefully, do you remember with negative exponents how you handle it? You can get rid of the negative exponents by moving them up and around. So when you do that, what you're going to get, this is going to become 4. It'll be 2 to the +2 squared and 1 to the +2. And then this is 4. I'm just going to do 1 cubed, which is 1. 2 cubed is 8. Now, if we continue the simplification, this here, 2 squared is 4. 4 times 4 is going to be 16. So it'll be 16 over here. 4 times 1/8 will just get to 1/2. So it's going to be 16 and 1/2. Clearly, these two are not the same answers. Okay, this one is still using the same function, but this time they want us to put a binomial expression in for x. So they want us to find f of q plus 1. Fine, wherever x is, I'm going to put q plus 1. So let's do that. We'll get 4 times 1/2 and then q plus 1. Now again, this section is really challenging your recollection of exponents. Do you remember that, if you, for example, if you had x cubed and x squared, do you remember those could actually come together and it would be x to the 3 plus 2, which is x to the 5th. Well, because we can do this and it's combined, we can actually reverse this one out. So what they're going to do here for simplifying is they're going to do 4 times 1/2 to the q power times 1/2 to the 1st. Then they're going to say, wait a second, 4 times 1/2, that's the number 2, and then they're going to keep 1/2 as a q. And that's the answer. Now, let's actually use more of a quadratic equation format, which is right here. It's 2x squared minus 4x plus 7, and it's f of x. Let's use that to find f of negative 3. So again, I'm just going to put negative 3 in for x. So 2 times negative 3 squared minus 4 times negative 3 plus 7. Be careful here on PEMDAS. We would do negative 3 squared first. So negative 3 times negative 3 is positive 9. So this becomes 2 times 9. A negative 4 times a negative 3 is a plus 12. And then plus 7. So what we have is 18 plus 12 plus 7. 18 and 12 is 30. Plus 7 will get us 37 as a final answer. Another format is what if we put a binomial expression in for x. So what we have to do in this case is put this in for x here and here, and then be very careful in our distribution. So this would be 2, and then in parentheses x minus 1 squared minus 4 times x minus 1 plus 7. Now be careful, we do have to do exponents before we multiply with PEMDAS, so we have to do x minus 1 first. And be careful what it means. I'm going to keep the 2 there. This means repeat that twice. So it means I have to multiply that, which therefore means I'm going to have to come on here in and do my distribution. Okay. Going forward, let's look at this. I'm going to distribute the negative 4 to both pieces. So negative 4 times x is negative 4x. Negative 4 times negative 1 is plus 4, and then plus 7. Okay, let's do this multiplication. So x times x is x squared. X and negative 1, negative 1x. Negative 1 and x is negative 1x. And negative 1 times negative 1 is positive 1. I'm going to keep that in parentheses because I still have to multiply this 2 through. I'm going to go to this back half. I'm going to keep it as negative 4x. I'm going to add 4 and 7 right now and get 11. And then why don't I combine maybe these like terms here first? So x squared minus 2x plus 1, and then minus 4x plus 11. I'm going to wrap it up by distributing that 2 through. Gives us 2x squared minus 4x plus 2, and then minus 4x plus 11. I'm going to add like terms and put it in standard format. So 2x squared is first, negative 8x, and then a 2 and this and 11 plus 13. This is the final answer in standard format.